Everyone for joining us today on the Cloud Native Islamabad webinar. And today we are talking about supply chain security. And supply chain security, I think, has been a topic that's everyone right now is being everyone. I think if you are being to KubeCon LA or join virtually or going to in person, I think most of you're familiar with how important or what the concept brings to the table for the larger audience. And today I'm really happy that I'm joined by Jim Bugwadia from Nirmata Cloud. Nirmata is a company who's the main, who is I think the makers of the Kyverno tool. And Kyverno, I think we have done a lot of we've done the session. If you're completely new to Kyverno, we have the session available on the YouTube, securing Kubernetes clusters using Kyverno. That's available in the Cloud Native Islamabad. It's been available on the YouTube link if you're watching this session from the YouTube as well. So before I wasting a lot more of your time, over to you, Jim, and we will talk about supply chain security, Kyverno. Let's introduce the agenda of the today.
Awesome. Thank you, Siam. Thanks everyone for joining. So yeah, just as Siam introduced me, I'm Jim Bugwadia, co-founder at Nirmata, also one of the maintainers at Kyverno. And yeah, we'll talk about some of the things we've been, kind of working on with the community for supply chain security. Simon, like you mentioned, not only were there topics in the main event, there's also like a supply chain conference this year at KubeCon, which was very popular, well attended. And hopefully we'll also see at KubeCon EU and other things as the community grows and awareness grows along this topic, right? Yeah, so first off, just I think a lot of you have probably seen the headlines and some of the presentations and buzz around this area. But just to kind of level set and say what is this all about and why does this matter and why now, right? So obviously, some of the events that have happened in the last like 12 to 18 months, and this whole topic is not new, right? You can actually go back and you will see even in KubeCons from a few years ago, and there has been work with projects like Notary and Tough and others in this area for quite a while. But what's happened is there's been this escalation as attackers have seen that perhaps maybe production secure systems are getting a bit more secure, and people are understanding how to manage application and cloud, and maybe even to some level cluster security. Attackers obviously like being perhaps leaning more towards the lazy side. They're going to look for easy ways in, right? And it seems like supply chain, and what we mean over here by that is really the CI/CD, the build tools, the systems that we use to build, package, and deploy software have not been secured with the same rigor or the same level as some of the production systems. So that's become an entry point, and we're seeing more and more, of these exploits. And some of these have been, of course, have made major headlines. And there have been has been a lot of activity around, kind of getting more security, more best practices, and focus in place for these part of the whole software development tool chain, right? The other challenge here, and it's a little bit, again, all of us have installed packages on Linux or any other system or Windows or Mac. But when we see all of that data fly by, none of us are really paying attention to what's really being pulled down, where it's coming from. We're trusting our package managers, our tools, to do the needful, right? So to make sure that these packages are signed, they're coming from a verified location, and we're trusting the authors to make sure that when they have bundled their software, they have also taken the right precautions. So two things to think about: what do we do in the cloud native world, right? So if you're running an image, just like you see all those bits flying down and things getting installed on your system when you install a package, each image may have dependencies, may have several other things. All of that is getting pulled into your production system. And you're trusting not only the author of that image, but recursively, any other base image. And if you go, further down into the code level, all of the things that the code has included, all of that has to be trusted for it to run in your system. And I mean, there's no easy way to go and check, inspect every bit, or and try and make sure everything is what it should be, right, or what we feel it should be. So that's the daunting nature of this problem, to say, how do we the only way to solve this is to start from every time there's a code commit, there's a change in a repo, there's an update, to make sure we're doing things the right way and the secure way, right? So that's where there's a lot of interesting tools and things being developed, being built to help secure this, and that's some of what we'll talk about, right? So I want to introduce three concepts, but which, and I guess some of these are more than concepts, they're tools and projects. But there's three things we'll talk about, right? One is a framework called SLSA, or SALSA, supply chain levels for software architects, as you see here. We'll talk about the Sigstore project, which is a Linux Foundation group, which is doing a lot of great work in this area. So this is one awesome community to get involved with. And then I'll talk about Kyverno, which is what I know best in terms of what Kyverno is doing in all of this and how it can help, right? Um, but before I go to that, Siam, any other questions, any thoughts on the introduction, and then we can dive into each one of these and see some demos and what you can put into your clusters and how you can start leveraging this now.
Yes, absolutely. I think that's a wonderful introduction. I think you shed a wonderful light on why this is secure, because I think all of us, I think every company in the world right now using 90% of the open source software in the form of NPM packages and these kind. But these packages are kind of really interesting to be integrating into your system. And shed some light on this point, because we are in the Kubernetes world, securing the code, securing the clusters. We are in the phase of securing the pod, internal communication between the pod. But we haven't been into this space yet before the arrival of Project Sigstore, Cosign, and Kyverno, these tools that spring up. When we pull the images from the Docker Hub or the Red Hat QA registry or GitHub Container Registry or ECR or ACR, when we pull the images, uh, shed some light on it, why it's so vital when you pull the images and push the images to sign those images as we moving along, why this is so vital, and if we don't do it, what are the circumstances we're going to face later down the road.
Right. Yeah, no, great question, right? And signing, as we'll talk about when we get into some of the details, is one step in the overall, kind of managing the security, but it's an important step, right? Because just like today, when we all know that, okay, don't trust a non-SSL website. We all know, don't trust, kind of, if somebody is installing a package registry again, if you're doing, whatever your package manager is, like apt get and stuff, you're running commands, you're not going to trust an insecure kind of repo. You want to make sure that it's from a valid source. So similarly with images, that you want to follow the same best practices, right? So you want to make sure it's coming from a registry you trust. It had the registry has the right security, but now signing that package at least ensures that somebody who was holding a public private key pair at some point in time, you are now authenticating using that public key before you're allowing, right? So it's one additional safety net you're kind of putting into place to make sure that that image was really signed by someone you trust and they have verified. So one of the things we'll talk about is your at admission controls. It's not like we can open up the image and scan every bit and inspect every aspect of what's happening, or how that image was built, right? So signing gives us that proof point to say that. And of course you want to make sure you know which key was used, or as we can see, as you'll see in the demos, there's new innovative ways of doing this in a keyless mode too. So using that, you want to trust the identity of the person who was signed that particular image. Beyond that, there's also important other checks which need to be in place, but it's kind of gives you that first step to say, I now have provenance. I can trace back and see, okay, who signed this, and ideally you're using some of the other tools which become transparency logs, which even register when that person signed and from where they signed that image, and all of this gets recorded, right? Which can be then checked later through metadata or other means.
Yes, absolutely. Wonderful. I think you can start about this SLSA. And meanwhile, we have a question around it. I think we covered this on the first webinar with Etienne. Kyverno. At Kyverno, some of the people throw out this question that does Kyverno works outside? I think its work on cloud native stack. Does it involve business policy and securities or not? I think we have covered this details on
Mhm.
the first webinar on the Kyverno side.
Right.
And when Jim goes to that Kyverno part of it, we will discuss more about this. So now,
Sure.
Jim, you talk about SLSA because I haven't dig
Yeah.
into it before. So tell us about
Right.
SLSA.
Okay. Yeah, so SLSA or SALSA, is again a security framework, like it says here on the screen. It's a set of guidelines for how to approach your software supply chain security, right? It originally came out of the work, and you know Google uses a variant of this internally for how they do their binary authorization. If you're familiar with that feature on GKE, how they use this even internally in their software development, and this is being widely adopted as a framework for saying how do you go, and it defines the four different levels like you see over here in for software supply chain security, right? And we'll look at briefly what each of these levels does. But you start from basic checks, to going to maximum protection, which includes things like even two-person code reviews, having some proof points for that. So being able to go back and track everything in terms of how your image was built, how you're managing your software, your build system itself, right? Now, keep in mind the premise here to get to advanced levels, you have to be able to prove that your build system is well protected and secured and is a trusted entity as well, right? So that becomes an important, part of this, and we'll see like some of the steps involved. But one thing which is interesting to look at, like this picture shows, the different types of attacks, right? And it's interesting to understand. I can make this a little bit bigger. If starting from a developer, kind of writing code, reviewing code, and even reviewing PRs and merging them, to like all the way till now we're delivering. In our case, the delivery is a container image running in a pod in Kubernetes, right? So that's kind of our assumption. uh, but if you look at this whole chain, there's so many different ways that system could be compromised, right? So if you bypass a code review, if you have like maybe I don't know for why you would do this, but let's say you just automatically merge any PR that's submitted. You don't know what somebody submitted, but it gets merged into the repo. And in open source, of course, with the some of the larger communities, there's lots of PRs, lots of submissions coming from many different places, right? um, you could have a compromised, even a source control system. So what you think you're committing may not be actually what gets committed if your Git system can't be trusted, right? Somebody may, kind of tamper with the bits maybe before you create your build. Maybe you have you're not missing like branch protection, things like that, right? Your build system itself could get compromised, or somebody could, maybe you pull a dependency, you don't know, that maybe is it really the package you think it is, or the library you think it is, who's written that, can they be trusted, and should that be pulled? And then CI/CD, of course, in best practices in most open source projects, especially CNCF projects, are required to follow a set of, best practices. There's a lot of automated checks that can happen in CI/CD, but those systems, again, if they're not protected and secured, can be compromised, right? Or bypassed completely. And same thing if you're pulling things from a package repo. First off, making sure that somebody can't pull from any arbitrary repo, and then making sure that the package repo itself is trusted and run. Now, keep in mind if you're using a lot of hosted services, cloud managed services, you're starting to get a lot of these. You of course have to go and validate the security posture of all these systems, but in the majority of the cases, a lot of this is taken care of, right? And that's one of the advantages we get from using these systems. And the final one they're talking about here is the package itself is, kind of bad or replaced, right? The one they don't talk about is like even getting to the consumer. There's, and maybe that this is sort of what H is pointing to. When we are in the Kubernetes and cloud native world, you're still pulling images from a registry. You're still, which is why it's important that not only do we pull by, we can check the image initially by a tag, but we need to immediately switch that tag to a digest at admission control. That's very important. And then even if you have a digest, it's just referencing, a particular, what you got back from the image registry. So then signing is important to make sure that yes, nobody has tampered with this, no, nothing has, and it is actually the package you expect it to be, even beyond just checking the digest, right? So that's what we'll look at in terms of what some of these tools provide. But at the high level, that's what Salsa does. The framework. There's a lot of details and a lot of great documentation here. These are the four levels, and it kind of breaks things down into everything from how you start with basic best practices, some more advanced things, having, as you see, like isolated and sealed, protected build systems, being making sure builds are reproducible, and data, and we'll talk about why metadata becomes important in this, is proving things, parts of your build system. So yeah, maybe it's a good time to just quickly touch on that. One of the things you'll see in these frameworks is, and I alluded to this also up front, is when you're running a container, it's not possible to do every check at that point. Obviously, when you're ready to deploy your workload or pod. So the admission controller in Kubernetes gives about 30 seconds at the max to complete the request. In most cases, if you take more than a few seconds, your cluster starts kind of your operations can get impacted. So the best practice is to keep it to this as short as possible. So how do you verify all of this if you have such limited time? So that's where there's a concept of attestations that comes in, which is very important. And it's kind of it almost inverts the paradigm a little bit, flips this around. So instead of, let's take an example. Instead of running a vulnerability scan before deploying your image at admission control, what you want to do is you want to have an attestation which can prove in a reproducible and non-falsifiable manner that the vulnerability scan was run, and you can inspect the results of that scan, and of course you can check and see that that was performed in some adequate duration, like the last day or the last week. And you can say, okay, only allow this image if I can have this signed metadata, which is the vulnerability scan result, and it's signed by the right person or right build entity or tool, and it has the right data which I expect before I allow that image to be run. So it's kind of, it flips the paradigm around to saying you're not performing the scan at admission control, but you're checking an attestation that the scan was correctly done and the image you're running passes the criteria, the standards and guidelines you've set for your organization.
Yes, absolutely. On the topic of attestation, I think before this SLSA, uh, people who don't have this kind of who are implementing this, I think right now the approach they are using is they pull the images, then they are, I think, using the sneak CLI command or the anchor tool to understand what are the vulnerabilities they have, and then they see the report in top of it that these are the vulnerabilities we have, and then they remove the vulnerabilities and make it more secure, more secure, and then they deploy to the production and this. So how this approach is different that you already discussed. I think you shed a
Right.
wonderful light on there. So just compare the two different approaches that we are
Yeah.
using right
So I mean, certainly you would go through that cycle of scanning, checking, removing vulnerabilities in your CI/CD pipeline, right? So those have to be prerequisites. Here, what we're doing is before we are running that image. So right where, if you go back, into the picture we were looking at, in this H where it's going to our cluster, being the consumer in our case, we want to make sure that this image was really scanned, verified, and it doesn't contain any high vulnerabilities. Or if there's a new vulnerability published, we are able to now change that, the metadata which we are pulling and checking to say, hey, this image is no longer allowed, or I want to even audit running images and take some action, or at least report those, right? So it doesn't do away with the need to you have to still scan, and kind of do this. The additional step here is taking that scan result, pushing it into a metadata system like In-totto, or as you will see with some of the Sigstore projects, Sigstore tools are even allowing us to push this metadata into an OCI compliant registry. And this metadata, along with the image, now you're doing these additional checks at admission control and periodically at runtime to make sure that the images running in your cluster have not just the signed, they have the right digest, they are signed by the people you expect to be verifying these images or signing these images, and then they also have these additional attestations. Now keep in mind, all of this can change. So when you deploy an image, maybe it passes, there's no known vulnerabilities, everything's good. But a few days later or a few weeks later, there's a vulnerability published. How do you know which images are out there which have that issue? So you have to periodically be able to scan even existing images, and you have to be able to change these attestations for more if there's a known vulnerability, to say, okay, now for this particular image, here are the requirements, or here's what we're going to do to before it can be safely run in one of our systems.
Yes, absolutely. Thank you very much. Wonderful elaboration. And now you can go through on what your topic discuss.
Yeah, so let's move to the second part, right? And each one of these is a could be a presentation on its own, so I'll move quickly
Yes.
because I want to get to some of the demos. But certainly, if you haven't looked at it, go check out Sigstore. Awesome community. There's a, of course, there's a Slack channel and workspace. There's community meetings. So it's a CNC. This is a Linux Foundation project, and Sigstore is a set of tools which are very useful in signing, verifying images, and even there's some new innovative ways to build this trust and transparency in your kind of full supply chain. So their focus here, the mission here, is to make these tools available to all open source software projects, the ones like Kyverno, or even Kubernetes and Prometheus, and pretty much all projects. And a lot of projects, including Kyverno, have started using these Sigstore tools to start signing their images, and even other community driven tools to start building things like software build of materials, which can also be then attached as sign attestations to your images, and then verified, right? So the whole idea here is just like, if you read through the blogs and posts, the whole idea was, just like Let's Encrypt made it so super easy to get certificates generated, and this kind of we saw this significant increase in using best kind of proper certificate management using tools like Let's Encrypt, and then with other tools like Cert Manager, etc., which made that very simple and straightforward to do. So the question became, why would you not do that, right? It's so easy. Why would you not run these tools and secure your services or websites in that case? So similarly, Sigstore is trying to make it so easy to sign container images, manage container, not just images, but even these attestations. That why would you not do it, right? It's simple, it works, it's reliable, and there's open source and free ways of doing this, which is the mission of this project, right? So within this project, there's several important tools, and there's actually three main tools we'll talk about. And I think somewhere in here, let me see if I can find where this is. But if you kind of go into the Sigstore projects and kind of look at how it works, the tools that we are going to look at is Cosign, which is the first tool for signing images and talking to OCI registries, right? It's a can be used as a command line tool. There's also an admission control webhook, and I'll show we won't use this webhook, but we'll use Kyverno policies instead. But there's tools here which you can start using, to sign and verify images and metadata for images. And by the way, Cosign can sign anything, right? So you can take a blob and you can sign it, and it just makes that again extremely simple. The other tool which works along with Cosign, and we'll see how all of these come together, is there's a tool called Rekor, which is a transparency log and timestamping, right? So it provides this way of going back and verifying that, okay, was this actually signed, who signed it, when was it signed, these things. And it's a tamper proof log, right, which can be maintained for this data. And finally, there's Fulcio, which is a way of making it easier to manage keys. So it does something very cool. You might have seen some reference or demos and things which talks about keyless signing, right? But it's not really, just like serverless is not really without servers. Keyless is not really without keys. There are keys involved, except it just automates the process of generating keys. It's using OIDC, and I'll show a quick demo of that. This is a very new feature. We haven't even actually officially released this in Kyverno, but I'll show this in terms of how Kyverno can also support keyless signing and verification for your cluster, right? So these are three tools that work together to solve some very important problems as they build on existing technologies, of course, like with certificate management, OpenID Connect, things to that nature, which all come together to solve this for us. Any questions or thoughts on that, Sam? Or
No, no, wonderful, wonderful. I think I think the just elaborate on the skillless part of it, so people who are listening or watching
right,
this session can understand it. Because as you mentioned, the serverless is nothing that the server is not
right,
anywhere. It's there, but you haven't think about it. You think about
exactly.
it. Yes. So just on a few words on the keyless part of that full seal.
Yeah, I'll show how that works. So then that will kind of will solidify the concepts, because and at a high level, what it's doing is it's using well-known protocols, security protocols, identity management protocols like OIDC. So it makes that connection, and once you verify your identity with OIDC, Fulcio will be able to then it generates, so it has a root CA which you can customize, or you can use the public root. And if you use the public root, it will generate a new certificate, a temporary certificate, which is only valid for like something like 20 minutes by default. It will sign your image with that certificate, but then the transparency log contains has the that record of the fact that this was signed by somebody who has a trusted identity. The identity is logged. It was also signed by someone who held the right key pair at that point, and all of that information gets logged in the transparency log. So then when you're checking, instead of checking for with the public key, you are now using the transparency log to verify, and with the combination of the identity you expect, right? So that's what's happening underneath, and we'll look at that live as we take a look.
Yes, absolutely. And one question from the audience there: how to secure a code in microservices architecture against common vulnerabilities like SQL injection. I think if we remove the SQL injection a bit and then remove that, how you will remove the
Right.
vulnerabilities. I think that's the question. So I think we have discussed about is about the code is we have a common vulnerability explorer
Hmm.
CVEs, the database, and we have some find these vulnerabilities from the database, and we have tools available. But you can shed some light on it, uh, how we can secure code in a microservices
Right.
against common vulnerabilities.
Right. Yeah, so the architecture, whether it's microservices or a monolith or any architecture, I think the best practices remain the same, independent of the application architecture, right? So the what you would of course want to think about, and if you kind of look up the Kubernetes security docs, there's the hopefully everybody is aware of it. If not, there's something called the 4 C's of cloud security, right? And they talk about infrastructure and cloud as being that first layer, clusters being the second layer, which we're building on infrastructure. Then you have your containers being the third layer, where you're running these containers in clusters, and then you have your code, which is running inside the container, right? So it's very important to secure every layer, right? It's not just, you can't just secure the code and ignore the rest. You can't just secure your cloud and or your perimeter and ignore the rest. So you have to do the vulnerability scans on your, of course, on your packages, on your software. There's like several open source and other great commercial tools available for that. What we the again the additional step here to think about is, even if you're performing the scan, how do you make sure that what's running in your cluster is actually what you scanned and what you
Yes.
signed and what you believe it is, right? So this, as we saw in the SLSA framework, there's just so many different points of attack where people could potentially change things or do something else, right? So that's what this whole software supply chain security is about, and building that trust and security from the beginning in every step, and then being able to verify that. So that's what, again, when people talk about zero trust also underneath that, I mean, there is some trust. It's just that you're always verifying right before, at the right time, right? You can't just do perimeter security and then say everything's good. Once that's done, you have to really verify right before use, which is what Kyverno and admission controllers can help us do in the context of Kubernetes clusters.
Yes, absolutely. And you can show us the demo so we can
Sure.
see how
Yeah.
easy it is, with Kyverno and Cosign.
Yeah, so just kind of quickly looking at the just for if folks are not familiar with Kyverno, so Kyverno is a policy engine for Kubernetes. It acts as an admission controller. This is kind of a architecture sort of block diagram, which is showing where Kyverno fits in. So in Kubernetes, every request, of course, any API request flows through various phases. It will go through authentication, authorization, and then it will also go through mutating, validating admission controls, right? So Kyverno registers itself in that admission control flow, and based on your configured policy set, will be kind of inspecting what's going on in your data, how you're going to be and you can kind of apply validation rules, and you can block and reject things based on what's in the admission request. And also you can look up data from your cluster, you can look up data from config maps. So lots of interesting things to do. Kyverno also allows generating new configs on the fly. So that's an extremely powerful feature for automating security, and even like doing fine grained like roles, things like that, you can automatically create. But here, what we're going to focus on is the, what Kyverno offers for supply chain security, right? So I talked about attestations. I want to quickly introduce, this standard, which, In-totto is another Linux Foundation project, which has, a standard for attestations, right? And this is like an example of an attestation, and each will contain a statement. It's a signed statement, and then it contains predicates which you can use, and you can verify that this was the right builder, things like that, right? So a lot of interesting things you can check. A simple example here would be, and actually the demo I'll show is something like this, is like where it's saying that there's a code review performed. It was performed by, Alice in this case, or Alice was the author of the code, and Bob, kind of reviewed the code. So this becomes, an attestation once you sign it, and you then store it back into your, common repo, which can then be verified, right? So just wanted to kind of quickly introduce that. But going back to Kyverno and what we'll do, I'm going to actually switch to my console, and we'll just show, a demo over here. So let me, hopefully this is big enough, or let me know if I need to adjust anything.
It's visible. It's look
Okay.
small.
So let's check and see what's going on in my cluster. I already have Kyverno running for, a couple of days. This is a Minikube cluster I'm just using locally. And if I do get cluster policy, I don't have any cluster policy. Let me check if I have any pods running. So I do have this let me just delete that and we'll clean up. Um, yeah, I don't know what that was from. Probably some other test or something I was doing. All right. So what I want to do is I'm going to show, maybe going back to the web page for a bit. What I want to show is um, an image that I just use for demos. It's the pause container used in Kubernetes, and this I am hosting on the GitHub container registry. And by the way, I see there's a signature here, and I'll explain what that is. But I'm just going to delete this, and we'll start over, right? So let's see. Let's assume that there's no signatures. There's nothing in this registry. So it's basically just a standard image. It's one of the ones that I have in my personal kind of GitHub registry, and it's a very simple container with just the latest tag, nothing else, right? So now what I want to do is I want to, if I try to deploy this right now, of course it should be allowed to run, so we can just make sure I don't have any policies. So if I just do kubectl, run, and yeah, is this the right image? Run test. Okay, so if you do that, great. Everything's running, no problems. There was no checks, so it basically just ran that, right? So we'll go ahead and delete it. Now what I want to do is I want to install a policy that says, no, I don't want anybody to just run anything. So I have some policies in this directory. I'll explain what these are, but let me just show you what happens if we apply a policy, and then we'll try it, right? So we'll use this policy to start with. And I'll show the keyless demo, because that's an interesting flow to look at. And then we'll see what happens if we add more attestation and keys. So let me run that. I'll also show what this, by the way, looks like. So if you, while that policy is being run, if we go and look in here, so this is what this Kyverno policy looks like, right? And here, what we have is basically it's a validation policy which says enforce. So basically, um, if this fails, it will block the pod. Then it's going to say also the failure policy is configured to fail. So if for some reason the webhook is not responding, and then it's saying check images for pods. And keep in mind, by the way, if you write a policy for pods, Kyverno automatically applies those to pod controllers. So you don't have to kind of write rules for each controller. And then in here it's saying match any image that's coming in. And I want to make sure that there is an email here And actually here it's saying Jim at Gmail, which is not a valid email, right? And I'll we'll switch that a little bit later to apply that. But then it's also saying, okay, make sure, and that has to be signed with this certificate chain, right? So I have, in PEM format, just a certificate chain, which happens to be my Fulcio root certificate in this case, right? So what I'm going to do now is, if we have applied that policy, what we should be able to, we can try to run that same image again. So let's exit out of this. Oops, wrong shell. So if I go back in here, and what I want to do is, let's run that same image we were trying to run again, right? So, well, actually, let's just make sure the policies are there. Good. So we have that. And then if we'll do pause to run, let's see what happens in this case, right? So now it's saying, oh, wait, there's no signature. So it's saying there's a mismatch. You can't run this image, right? Which is what we want. So what can we do with Cosign to fix this? And what are the options available? So I'm gonna kind of do this sign, but I don't want to sign because we want to first demo the keyless thing. I'm just gonna say Cosign sign, pause two. If I do that, I think it will fail because it's this feature still you have to run this experimental flag. So let's try that. Yeah, so if I run it with this Cosign experimental one, because the keyless part. By the way, Cosign is GA, like there's a 1.0 release. You can use this. This part about keyless signing is still wrapped in this experimental, and there's work going on to release that soon. But let's go ahead and sign this and see what happens, right? So actually, it says, oh, I did verify. I don't want to verify. I want to sign. So let's try that. So it's telling me something, that okay, there was a OIDC request, and because I'm running, by the way, I'm running WSL in Windows, so that's where it could not open up my browser directly. So that's why it's saying, oh, go to this site and enter the verification code, right? So let's see what happens if we go to that site and what that's all about. So if I go here, it's giving me from Sigstore some OIDC providers, which are the supported ones by default, and I say log in through GitHub, and then it's giving me a code and saying, okay, paste it back. All right. So let's go back to our terminal. We'll paste back that code. And at this point, what happened is, again, I didn't have to generate any certs. I didn't have to do anything. And you see there was a transparency log entry created in Rekor automatically, right? So all three tools that we talked about, Cosign, Rekor, and Fulcio were used in this case to be able to actually sign that image and push that, into my OCI registry. And just to make sure that that's what really happened. So let's go back here, and if we kind of refresh, I should see that now in this registry. Um, oh, actually, I'm in the wrong package. I want to be in pause two. So let's do pause two. Yeah, so pause two has a signature, right? Which is exactly what we expected to get published when they signed this. It says a minute ago, and this is so this hash, which is the digest, and the .sig is where our signature is stored, which we can then verify. So what should happen now is if I go and try to run this, it will, go and do, now Kyverno will apply the check, and it should say, okay, this image has a signature, right? But if you recall, when I signed this, I said, in my policy, in my Kyverno policy, I used, Jim at Gmail, but when I verified, I logged in through my Nirmata ID, right? So obviously that is a mismatch, and that is why Kyverno denied this. So let's go ahead and change the policy to say, no, it needs to be Jim at Nirmata who really signs this, and not some other random user. And I'm going to go ahead and apply that, policy back into my cluster, and then we'll try and run this image one more time, right? So at this point now the pod is up, it's running, and Kyverno did, and with Cosign did that check, verified not just that the certificate matches, but also that the right person, has that we have the right identity, and it allowed that image, right? So pretty cool way, which eliminates some of the hassle of managing keys, rotating keys, because now keys are temporary and they're generated on demand as needed, but we're using other well-established mechanisms to prove the identity and to verify that, as you saw, later on for that person. So that's that keyless part, and hopefully, kind of, I think the demo probably was easier than the explanation. So any questions or thoughts on that? And then I want to also quickly show how attestations work to wrap up the demo.
No, no, it's been a wonderful seeing this. So go to that station and then we will talk about
Okay.
some questions.
Sounds good. All right, so let's do a quick attestation check, right? So now what I want to do is, you remember in this policy we are saying that is signed. I want to kind of make this for various things. I want a review policy which is saying I want to have an attestation signed by some a public key that I trust, which has a code review, and I'm also going to check and make sure in that review metadata, it's coming from the right branch, it's coming from the right repo, and the reviewer has to be one of these reviewers, right? So we'll apply that policy, and we'll see, what happens next, right? So if I do kubectl apply, and I think the policy was called check review. So let's apply that. Let's delete, the pod we ran, and we'll try and run it again and see what happens, right? So if everything works correctly, Kyverno should say, yeah, this is signed, it's by the right person, but now, it was blocked because it could not, this code review attestation failed. I don't have an attestation for that, right? So to solve that, what we'll do is we'll do cosign, and there's a command called attest, where it's a very flexible command and very powerful. So you sign with a key, you can give a predicate, so any valid, in this case, in-totto format predicate, and you can kind of then push, so that you give a predicate type, and then you're pushing this back into your repo, right? So it's asking me, because I'm using public private keys in this case instead of the keyless thing, and you can have a set of keys for your organization. You might have other ways of managing group level or individual level credentials, right? So now if we go back to our registry, what we should see is, in addition to the signature, there's also this .att file, or kind of, that got pushed, which contains all the attestations for that image, right? So we have signatures, we have attestations. So let's go and now try to deploy this again and see what happens, right? And if we have the policy correct, if we signed it with the right attestation, everything should work. So I'll go ahead and just try to run that image, and it's doing some more checks, and it worked, right? So what, just to make sure it worked, let's try something where we change the attestation. So let's go back into our policy. And what did we have over here when we said check review? So we were saying, yeah, it has to be reviewed. I think when I signed it, it was reviewed by Bob or Anna. I think it was Bob. So let's try and remove Bob, and we'll check. You know, yeah. So this is the policy. Let's check the predicate. So here, what I want to do is, the review.json was the predicate, right? So yeah, it was reviewed by Bob, and we removed Bob. Let's reapply that policy. And let's try and run that image. So in this case, the review, so it has an attestation. It will, try to find that, but it shouldn't find Bob in the allowed reviewers. And sure enough, it said, look, the error message is different. It said the predicate did not pass, right? Because in our policy, we're explicitly checking for a particular reviewer. Now, Obviously, in production, you can kind of manage this through a config map and other data variables, so you can have this different set. But you get the idea for now how flexible this is to create these pieces of metadata, like code review records, vulnerability scans, even software build of materials, sign them, push them into your trusted repositories, and then be able to verify those added mission controls using Kyverno policies, right? So that's kind of the end-to-end flow, and what it does. Of course, we could add more signatures, we could do other things. And this is, by the way, this again, like as you saw, some of these features are still marked as experimental. They are going to be released very soon. A lot of people in the community are working hard towards that. So just join in any of the forums. And certainly we want to know about more use cases, things we can enable to further simplify and make this, like the mission for Sigstore, make it kind of like a why wouldn't you do this, right? Just make it so simple to manage security that our systems start moving more towards a secure by default state, even in the software supply chain.
Yes, absolutely. I think that's a wonderful demo. And then I see that same demos on the cloud. I think you did a session on cloud native TV, and that's been a wonderful session. And the demos depict the power of the tool. I think before this tool, I can't ever realize that what we're doing is we have a kind of a same pattern that the TLS using for the communication. We have the private and public key, and then we're a trusted root authority. We want to be secure our cluster, but that process is actually so painstaking that everybody able to not doing that process. But what you just showed is that's awesome. We haven't seen any keys in there. And if we can do this with the Let's Encrypt or another controller in the Kubernetes, I forget the name. So when you see in the output, there are so many certificate in the output, and that's really a jargon for everyone. But what you just demo out, we haven't seen any keys, and we can do the same process in the TLS and with the Cosign. I think that's a wonderful story. So I see as it because I've done a session with the Sneak on the Matt Jarvis joined me. I think when the Sneak and the other tools, when your image is uploaded, then they check about this.
Right.
They are, but on the admission controller with Cosign and Kyverno, you absolutely sure by the time of you deploy something else, you sure me like Sim is the person who signed the images and then deploy the images into the cluster. So anything happens to the cluster, you can pinpoint the person who created the image. That's a
Right.
wonderful. So I think we talk about it, we demos out. Now tell us why that is so important. And I think that there are terms around SLSA, SBOM,
Hmm.
zero trust. You already
Right.
explained. So just explain in a few words so people who are listening to us can understand, especially on the SBOM side, because this term is
Right.
introduced a lot in the KubeCon.
Yeah, so SBOM is an acronym for Software Build-up Materials, right? And like the acronym suggests, what it is a detailed record of exactly how what went into your software, how it was built, all of the packages, things like that, right? And there's a couple of standards evolving. There's a pretty sort of also a wide awareness of the fact that it's important not just to know what you're using, but also kind of go a couple of level, or as deep as possible, down to the base images and containers, right? So the good news is also, by the way, if you're using things like distroless for base images, all of those distroless images are getting signed by cosign now. So you can check for those before you include them, and then your SBOM will include the fact that okay, you're referencing those images, but at least now you can verify each step of that build and of that dependency chain, right? Which becomes fairly complex, but these tools now have simplified the job where you're able to verify that. So the idea would be even with SBOMs, and we're looking at how to integrate this with Kyverno, is being able to automatically then check for certain parts of the SBOM that you're expecting. So first of all, making sure that there is a signed SBOM, and then secondly, verifying some of its contents become a critical at admission control. So just like we saw with attestations, and a code review attestation as a simple example, an SBOM would be a much longer document like that, which can then
Yes.
also be trusted and verified.
Yes, absolutely, absolutely. Thank you very much. I'm really confused about this term. People are throwing a lot at me, and I'm really confused what it is and what. So wonderful session. So before I let you go, the final question from my side is, what you just showed is a wonderful. You explain. I think that's so really important for any cloud native application at this moment of
Mhm.
time. But the question is at the team of the Kyverno and the Nirmata. I think Cosign and is not a very old tool. I think it's developed in recent 2 or 3 months ago, and in the shortest amount of time, Kyverno inject those policies and use Cosign, Rekor, and Fulcio underneath that, and providing us the information in the mutation and validation webhook. That's excellent. But my question is how fast it is, and what was the reason is how fastly integrate into the Kyverno.
Mhm. Yeah, so I think it's just the importance of this is, of course, hopefully clear to everyone, right? And I think that the our goal at Kyverno, just like we are doing for Kubernetes configurations, is to again, make it easy to be secure by default, right? And make it like a why wouldn't I do this, and have proper pod security and workload security and other things for any production cluster, right? So similarly, when we kind of looked at Cosign, and as we are talking to, of course, other adopters and customers and users of Kyverno, and even on the Nirmata side, some of our commercial customers, this has become a top requirement to say, how do we get this basics? So at least today, there's a lot of things moving very quickly, and sometimes this can seem overwhelming, but um, making sure that images are signed and verified is a no-brainer, right? That is something that, as you saw with the demo, it's extremely simple to do. It's with Cosign and with Kyverno, you can verify those at admission controls. So definitely putting that basic, the first step, the foundation in is required. Now beyond that, there'll be, there's a lot of interesting other topics to cover to say, what else should we check? How do we get to the next level of salsa? What are our organizational goals? And those are bigger discussions. But so I would strongly suggest that everybody, and the reason why we rushed, to make sure that we have proper support in Kyverno and make this as easy as possible, to say let's at least make sure that's basic verification of image signatures is available and is easy to use for everyone as quickly as possible.
Yes, absolutely, absolutely. So wonderful news for me. With the Kyverno, I think the team is really wonderful. Not many years ago, that Kyverno is a newly project, but I think the amount of appreciation, the popularity, and plus the contribution, I think just simply awesome. 1K stars on GitHub, and so many audience always talking about, and so much resources I think right now available on the internet in the policy and admission control side. So last few words on what's coming up next, so I can plan accordingly for the future webinars as well. So what's coming up next with the Cosign and plus on the Kyverno, the whole community, what is talking about, what is currently happening?
Right. Yeah. So in the Sigstore ecosystem, there's a lot of course, activity and work to bring. Cosign is already, I think it's at 1.3 in terms of the releases, with Fulcio as well as Rekor. The plan is to kind of, move them out of experimental and into a production ready and deployment ready kind of state, right? With Kyverno, we will continue, and we're working, with Sigstore, also with the In-totto community, to see how else can we, provide easy controls for admission controls. We will, have more support for also other built-in checks for things like SBOMs, image vulnerability scans, things like that, which you will want to verify before any deployment into your, cluster, right? So there's going to be ongoing work for that. There's lots of, we just put out release 1.5 for Kyverno, and lots of awesome features. One thing, as you saw, is now at a very granular level, you can choose between fail close, fail open for webhooks. So that is with webhooks, that's a big pain typically, because, if you put everything as fail close, you might end up, misconfiguring and, hosing your cluster. So now Kyverno automatically manages those, webhook configurations dynamically, which is extremely powerful, and provides a lot of flexibility. And also other more features to make it easier, like we introduced for complex policies. You can do things like, there's a for each block. So several new things coming up in Kyverno, and we'll continue with that momentum. So, and it's extremely exciting to see the adoption and feedback from the community.
Yes, absolutely, absolutely. So same question as always. I talking about these kind of tool in the chat. Kyverno, Opera, or Gatekeeper. I think we have a wonderful conversation in the past. I think we have a whole session on Cloud Native FM on the Cloud Native
Mhm.
Islamabad YouTube channel on that particular topic. But I think, okay, correct me if I am wrong, but I can, because I have a session with the Opus people and also with the
Mhm.
Kyverno. I think it's simple. If you are in the Kubernetes, I think Kyverno is a simpler option. And if you are outside the Kubernetes, Kyverno is not there. Go
Mhm.
choose OPA, wonderful community, wonderful tool.
Right.
But into the Kubernetes, you use Kyverno because of that simplicity. And if you use, and also the intelligence it's bring to that tool, because if you inject the policies for the pod, it's auto inject policies for the replica set and deployment. I don't think so OPA does this. And also the policies the OPA with the written is required you to be a PhD or at least a MS in the Rego language. That's really a difficult and the pain point. But if you are into the Kubernetes space, Kyverno is a good option. Outside the Kubernetes, Kyverno is not there. Hopefully, in the future, it will be there. Also, the policy repaired reports are missing in OPA, and Kyverno has a policy reports feature. So I think it's it's all on the use case scenarios. But that's my comparison up to this point. But Jim, final thoughts on OPA or Kyverno?
Yeah, no, that's a great way of approaching it. Those are the major items. One other thing to add is Kyverno also can be used for automation of configuration, right? So dynamically generating new configs, kind of doing an, IFTTT, like if this, then that. So if a namespace is created and it has a label PCI, inject a node selector, things like that you can do very easily with Kyverno. So it's designed not just for validation and enforcement, but automation of security as well.
Yes, absolutely, absolutely. I missed up that spot. Automation is really important because the policies are injected via the Kyverno CLI and on the on part of the CI/CD build system. That's really important. As we also saw today, how easy it is during the before the deployment, you can inject the admission controller to sign the images. I think that's
Right.
really wonderful news for everyone who are watching this channel. I think they really appreciate it. So get involved with Jim on the Slack, Kyberno. All these things are listing on the YouTube if you're watching the session from YouTube channel. So I think hope to catch up again, Jim. And Jim has two sessions with me in this year, and really enjoy that time every time I catch up with him, and learned a lot of the new things around the policy engines, the Kubernetes, the automations, and these kind of stuff. So thank you everyone who joined us today. Hope to catch up you again in the future. Stay safe, stay healthy. Bye bye, Jim, and thank you very much for your
All right.
time.
Thanks for having me. Take care, Sam.